Hello from Dendrite Digital in Santa Ana, California. I've made a emulator of the 65 CO2 and got it to work with the WOZMON program that Steve Wozniak wrote. And I have here at least a few commands that I can do, like I can take 0, 0, 3, 0, 0, and I can put the value, I can examine it like this, or I can change its value like this. See, that's a previous value again, but if we try examining it, it's now 77. And so I can change memory, change a byte at a time, and probably do a series too. Let me try that. Let me go 0, 3, 0, 0, 9, 9, 8, 8, 7, 7, 6, 6, 5, 5. Let's see what happens. So then if we go 0, 3, 0, 0, dot 0, 3, 0, 8, yeah, they're all there in the memory. So there's another trick I can do. The line that you're typing in goes in as data for hold on. I don't know what I'm gonna do with this. This is B0. Let's try this again. 0, 2, 0, 0, dot 0, 2, 1F, let's say. And so this that's where the command line goes in, is 2, 0. So yeah, this B0 is this 0 here. The B2 is this 2 right here. B0, B0, AE is the period. B0 is the next 0. B2 is the 2. B1 is the 1. C6 is F. And 8D is the return from the end of the comment. So, yeah, how about this one? You go FF00 dot FF1F, and you get yeah, the FF1F is supposed to be the entry point back into the WOZMON monitor. So if you're running a program and you want it to end and you have a command in there, have it jump to FF1F. Let me try showing the whole program here that's running. So here's WOZMON. That's what's putting things up here on the monitor. So yeah, how did I do this? It's all in JavaScript. See, we're up here in Chrome, and that's what's running this, is a browser. I have a 6502 in here in JavaScript. So yeah, how'd the magic work? Yeah, see, here's my 65C02 in JavaScript. And yeah, so I have all these like commands for putting things in and out, reset, etc. These aren't the 6502 just yet. So this is as absolute addressing, absolute X addressing, absolute Y addressing. Accumulator specified as the data. Add with carry. And arithmetic shift left. Branch on carry clear. Branch on carry set. Branch on equal. Bit. Branch on minus. Branch on not equal. Branch on plus. Break. Branch on overflow clear. Branch on overflow set. Clear carry, clear decimal flag, clear interrupt, clear overflow, compare X, compare Y, decrement X, decrement Y, exclusive OR, immediate addressing, implied addressing, increment, indirect. So it loads a 0-page address, and then no, it's loading a full 16-bit address, and then seeing if it jumps over a page boundary. And then putting the string, the disassembly version of this. Increment X, increment Y, interrupt request. Indirect 0-page. See, the X is inside the parentheses. 0-page index. And then here we have 0-page index Y. Notice it's outside of the parentheses, so it's a different way of addressing than here. It's indexed after you evaluate the address. So yeah, yeah, that's interesting. Jump to subroutine. See, we're putting things on the stack. We're putting the program counter on the stack, so it can come back to this point and start again. Load accumulator, load X, load Y, logical shift right, non-maskable interrupt, no operation, just wait a couple of cycles, or accumulator, push accumulator, push process status register. See, we have the status register, board with E and U. Oh, and programmable logic array. No, that's hardware stuff. It's pull the accumulator, and then pull processor status. Pull the status register. Relative addressing. That's for all your branches. I had this calculated wrong before, but now I got it working right. So yeah, and then roll left, roll right, return from interrupt, return from subroutine, RTS, subtract with carry, set carry bit, set decimal flag, set interrupt flag, store accumulator, store X, store Y, trade A to X, trade A to Y, trade status flag. No, wait. No, stack pointer. Trade stack pointer to X. Trade X to A. Trade X to S, which is a stack pointer. Trade Y to A. This is the illegal function. Hasn't been implemented in the 65C02. I hope to upgrade this same software to be a 65.816, but haven't got there yet. Lots of work to do there. Zero page addressing. Zero page X. Zero page Y. And then here's the table that I looked up all the functions I just read off, and have it do the operation and then go to the next instruction. That I have down lower here. And here's the WOZMON program. And yeah, so up at the top of this are the main thing that does all the work is here in clock. And clock, you read your opcode from the program, from where the program counter is. You increment the program counter, make sure it's 16 bits and not anything more. Cycle plus equals. So this is a thing that counts the cycles as it's being processed, so I can get the timing precisely done. You know, I can set the clock operation to happen as fast as I can possibly go, and then sum them all up with cycles for like 1/100th of a second in JavaScript. I'd look at the milliseconds and I go, oh, 100 milliseconds have passed, and then is the clock ahead of that or behind it? And I can adjust my programming that way. Yeah, and then create pokes in the WOZMON program and resets the computer. Yeah, I'm gonna have to go a long way before this is finished. So here's the thing that gets the data when the program needs it. It's the program. It's looking up opcodes, and each opcode has its own addressing mode, so we can process the data efficiently. And then get flag just returns like the flag that you specify, and of course that's in a status register. So you just AND the flag with the status register and see if the flag is off or if the flag is on. And set flag is just the reverse process. It's setting the flag in the status register to be true or false. Here it's doing false. It's inverting the flag and then ANDing it, which zeros the specified flags. And log, this is my trace algorithm. It sticks all the code that's running in the. I had to do that because I was having a bunch of bugs that were really nebulous, and I had to look at the code that was running, and I found that bug in the relative addressing, um, and yeah, I got it working pretty well. There's still I can't run addresses yet. I think there's something wrong with like the external hardware from the 6502 that needs fixing. Yeah, here's reset. Some little library calls that I made to display data in the correct format. Of course, write data out to an address on the system bus. Reads the opposite way from this. So, yeah, and we went through all these. Yeah, that's the 6502 in JavaScript. Thank you.